So I've got the diagram I wanted now. I've got my piece here that shows that the voltage is high, but just to make sure it's clear, I've written a little bit of text. The oscilloscope graph, which is what this actually is, an oscilloscope graph, shows that when the switch was closed, it had a logic high output. When the switch was open, the output was 0 volts or logic low. And that information is in the graph, and it is on this diagram. The reason I don't have the little red voltage bars was to be able to do a screenshot. I had to stop the circuit simulation. So then I've gone on, I've got my points that I'm testing. My circuit needs to run on 9-volt power supply. The block output needs to give a logic high output to trigger the logic gate. Tested by. So one of them is simple as I've set the simulation so that it's right. And I've set it to show explosions. So if anything was going to blow up because 9 volts was too much voltage, it would do. Put a voltmeter between the output and the negative rail. Well, actually, I didn't, so I'm going to change that. I have put a probe at the output and recorded the voltages on the oscilloscope readout when the switch was opened and closed. There we go. Oh, that's not how you spell it. My results. Circuit functioned correctly with 9 volts, and I had the right voltages in the right times. Conclusion on this one's fairly simple. Yes, it does what I needed to. It can be used in the system as the trigger input. The important bit to remember is when you're doing these, you need to be thinking about, right, so this bit needs a logic high to go to the next bit. It's expecting the input of the next bit to be a logic high. You're going through the same process. It doesn't have to be set out like this. I like tables. I like to be able to go fill in this box, now fill in this box, now fill in this box. Yes, it's done. Whereas when you do it a little bit more ad hoc, like the other example, you might miss bits out. You might not. It depends on how well organized and planned you are. But I'm a table fan. So you do the same process repeatedly for each of the blocks within your system block diagram, and you must say if you need to make any changes. So this conclusion is fairly straightforward. You could have a conclusion that says, I've just discovered that my output is logic low, and I need it to be logic high. Therefore, I'm going to make these changes. You then do the changes on Circuit Wizard, retest it, and drop that diagram into your conclusion. Having done that, I've now fixed the problem that I had. You need to do that for each section. You've got to have each block needs a system block testing sheet or page like this. And that then moves you on to the next stage.